design a race car, we start at the tires and we work our way inward. That being because the tires are the most important part. Tires develop all of the forces that cause the accelerations of the car. So all of the turning, all of the accelerating, all of the braking, those all happen at the tire. So we select the tire and then we work our way inwards. So design of the frame, for example, can't even begin until suspension geometries are selected, and suspension geometries are selected based on where the tire likes to be. Okay, so one of the biggest difficulties that we found in design of the suspension system was fitting everything within the wheel. So moving from 13 to 10 inch wheels, we lose a lot of real estate inside the wheel to put stuff, right? So packaging becomes a huge challenge. With the smaller wheel, we ended up having to redesign everything inside the wheel. And because of that, we would kind of move forward with one idea or concept and then realize that we couldn't get that concept to fit, and we would have to basically go back to the drawing board. So getting a concept that fit inside the wheel was a big challenge. One of the opportunities that kind of arose from it was being able to change brake calipers. So when we started design, we had started with assuming that we were using one type of brake caliper, and then after realizing that it was impossible to fit that brake caliper within the wheel, we began researching for brake calipers that kind of had the same performance but took up a lot less real estate, so were much smaller. And ultimately we found a caliper that between the four of them saved us about 1.5 pounds, so kind of provided an opportunity for weight loss through challenge.
So we changed the suspension up almost entirely. We changed the way we mount the suspension to the frame. We changed all the pickup points, changed the way we designed them. We also modified our engine mounts, and some of the tube sizing and thickness where we're outside of regulation, we were able to change to a smaller tube size as long as we were still able to maintain structural and torsional rigidity of the frame.
We looked at creating a frame that was more lightweight than previous years. In previous years we used tubing that was all pretty uniform across the whole frame, and this year we looked at adjusting tubing sizes so that we could save weight where it was possible. We did a lot of FEA to help with that. So the engine mounts is something that we saved a lot of weight on. In particular, the engine mount tubing is been adjusted this year to 0.035 and 0.028 thickness, which is something that ended up saving a total of 2 pounds for the entire assembly on the engine mounting.
So we were looking for a car that's right around 450 pounds. We're hoping that we can hit 460 pounds, including aerodynamics. So one of the bigger changes to the frame was semi-stressing our engine. So that allowed us to eliminate a lot of tubes and also use the engine as a stressed member of the frame, which means that the engine is actually adding to the torsional rigidity of the frame. And then on top of that, a lot of our frame guys went through a whole lot of the tubes and custom tailored the diameters and the thicknesses of those tubes so that they were no heavier than they needed to be. And so that resulted in a frame that looks like it's about 30% stiffer and also about 10% lighter. We're aiming for a 53% rear weight distribution, so a little bit more on the back to help with the acceleration of the vehicle and getting traction under acceleration, but not so much that it kind of sacrifices some of our front end grip.